Risks involved in servicing and maintenance of wind turbine generators. Once a tower is operational, there are many maintenance and repair procedures that must occur over the life of the structure. It is largely technicians who will access turbines to undertake these activities. The typical routine maintenance time for a modern wind turbine is 40 hours per year. Crews consist of 2 technicians for every 20 to 30 wind turbines. Thus, the more time that technicians do work to maintain a wind turbine, the greater their exposure to a WHS risk. Technician maintenance and repair activities include common tasks such as cleaning blades, lubricating parts, full generator overhaul, replacing components and repairing electrical control units. Management must remain alert because of the pressure on technicians to work efficiently, because of their high work demands, and because doing tasks repetitively is a strong temptation to take shortcuts. Therefore, constant reminders of the dangers and the need for good working practices is essential. So where is the greatest risk for technicians? Components with higher failure rates require more maintenance interventions and consequently place technicians in the at-risk location within the turbines. Components with the highest failure rates include the electrical systems, the rotor, that is blades and hub, the converter, electrical control, electronics and inverter, the generator, the hydraulics, and the gearbox, which needs replacement every 7 to 11 years into service. Gearboxes are a major focus for management because these cause wind turbines to be non-operational for the longest periods of time. So, it's essential to have good practices during service and maintenance activities of wind turbines. It is essential to identify, block, detach and free energy sources in wind turbines. In the past, there have been serious and fatal accidents caused by poor locking or disconnection of the equipment. Maintenance work in and around the nacelle also involves risks associated with rotating parts of machinery, the manual tasks done, working at heights, hazardous materials technicians come in contact with, hot parts that cause burns, and from live sources of electricity, rotating machinery. Moving parts of the turbine, that is gears and blades, should be guarded properly to prevent staff becoming entangled and potential of severe injuries such as amputations, crushed fingers or hands. Thankfully, today all turbines shut down before personnel climb the towers and the rotor is locked in place once they reach the nacelle. The manual nature of tasks. The work of wind turbine technicians is physical and requires a high degree of flexibility and strength. Additional risks occur due to the repetitive tasks that are done with poor ergonomics, such as in small spaces, and which involve awkward static positions that result in musculoskeletal disorders. Some staff cite a culture where personal discomfort is no excuse for not getting the job done. In addition to this is the high physical load on technicians from climbing very tall vertical ladders, especially where there is no lift or where the lift has failed. This may cause exhaustion and result in musculoskeletal disorders, so a high degree of cardiorespiratory fitness and limb strength is needed. There is also the potential for increased cardiovascular stress that occurs from working in a nacelle during hot weather. Heavy machinery also poses risks for technicians, particularly when moving them and using them within small spaces of the nacelle and hub. So how can this be managed? Assessment is governed by the WHS guidelines. Control measures can be difficult to enforce, but the first action is to eliminate or remove the need to perform the hazardous activity. A key question is whether it's necessary to perform a particular activity, for example every 6 months, just because an outdated or unreviewed checklist requires it to be done. Can something be substituted? Can heavier equipment be replaced with a lighter option? This is relevant, for example, where a particular tool that performs a job faster is being used, but where its weight and awkward use increases risks and increases physical demands on technicians. Next is engineering. Where available, technicians should use available mechanical lifting aids such as hoists or winches, torque multipliers and so on. Next is whether administrative processes can reduce or eliminate the risk. This includes making available written policies and work procedures, training and supervision. Emergency response planning and rescue plans are also a vital feature needed in wind turbine work, and technicians should receive training in rescue procedures, in evacuations from the nacelle, actions for any type of emergency, and different methods and procedures to use. In addition to the former is the use of personal protective equipment such as gloves and footwear. Working at heights. It's important to protect technicians from falls where fall distances of 1.8 metres or more exist. protection strategies may include guardrail systems, safety net systems, and personal fall arrest systems. In New South Wales, working at any height above ground level requires assessment and treatment to address the possible impact of a fall from that height, whether the height is 10 millimetres or 100 metres above ground level. The definition of a minimum height in Victoria does not require assessment and treatment. A key control measure is to eliminate the need to work at heights. This may involve using a crane to move equipment to ground level and for work to be carried out on the equipment there. Another control measure is to isolate or re-engineer the activity by providing safe systems such as fall prevention devices, handrails, enclosed platforms, hatches, and so on. Other examples include providing work positioning systems, such as an industrial rope access system where a fall prevention device is not practical. A fall arrest system is another example. It uses a safety harness and fall arrest device attached to the harness and anchor point to limit the distance of the fall and the impact on the body from the fall. Administrative controls include policies and procedures. An example is training on safe work at heights procedures, use and maintenance of safe systems of work employed, mandatory equipment inspection requirements, recording, signage and permit systems. The final control measure is the use of PPE such as a safety harness and hard hat. Working at heights also results in other risks, such as accidentally dropping handheld instruments or tools, particularly when working in the nacelle. Apart from the downtime spent searching for the dropped object, delicate instruments can be damaged beyond repair from the fall. Control measures in place at some wind farms include retractable gear attachment systems, which improve safety, productivity and comfort for technicians. This also prevents loss or damage to critical gear because if the instrument is dropped, the tether easily absorbs the impact. Exposure to hazardous materials and chemicals. Technicians come into contact with different types of potentially hazardous materials and chemicals. Wind turbines are made from a variety of materials and finishes including fiberglass and have protective coatings to prevent corrosion. Technicians use lubricants and transmission fluids in equipment including grease, oils, hydraulic fluids, as well as solvents and other solutions such as chemicals for surface preparation and those used in general cleaning. They also come into contact with potentially harmful materials or chemical compounds which in their normal state pose no threat but which under certain conditions such as during a fire release toxic gases and fumes into a small area or which release hazardous gases such as occurs during battery charging discharging operations and which can explode if ignited. Assessment of the risk to health and safety from exposure to hazardous chemicals is also determined by WHS guidelines with specific reference to safety data sheets. These provide instructions on the safe storage, handling and use of chemicals. Considerations of use of and exposure to chemicals in identified confined spaces within the workplace, requirements for response plans to manage unintentional events such as spills and accidental contaminations, application of signage around the workplace, and emergency contact procedures. Is it possible to eliminate the hazard? For example, is it possible to eliminate exposure by using pre-mixed solvents or smaller package solvents from decanting procedures? Is it possible to substitute something to manage the risk? For example, can non-toxic, eco-friendly cleaning solutions be substituted when undertaking general turbine cleaning duties, such as grease removal? Are there any engineering controls possible? Is it possible to remove airborne substances from the work area using natural or mechanical ventilation? For example, technicians can prevent concentrated gas buildup by ventilating battery boxes used for backup power. Administrative controls include written policies and work procedures, training such as chemical awareness training, and supervision for the safe use of chemicals and substances. PPE controls include use of gloves, protective disposable coveralls, respirators containing filters that address specific contaminants. Technicians need to know that specific filters remove airborne contaminants as detailed in the SDS, so the correct filter types must be fitted in a respirator to adequately protect staff when doing their work. Direct or indirect contact with electricity and high voltage machinery. Technicians undertake maintenance and fault-finding activities on wind turbine electrical systems. These systems may be complex and in some cases, due to the level of voltage sources employed, can be extremely hazardous to workers' health and safety when direct or indirect contact is made with the voltage source. Voltage sources employed within a wind turbine generator fall within the three ranges of voltage levels as defined in Australian Standard Wiring Rules AS NZS 3000 2007. These levels are extra low voltage, and high voltage. Extra low voltage values encountered within a wind turbine can range from 5 to 24 volts. For the purposes of definition, the physiological effect of coming into contact with extra low voltage is considered negligible. The physiological effect of either direct or indirect contact with low voltage values, however, represents a significant threat to life depending on the voltage and therefore the current value that the body is exposed to, the path the current takes through the body, and the exposure time. Effects of contact can range from mild electrical shock, flash burns, permanent disability through to death. Technicians can also be required to operate and maintain equipment that falls under the definition of high voltage. Operation of high voltage equipment comes with its own unique hazards, in that technicians don't necessarily have to come into direct or indirect contact with equipment to suffer adverse physical effects of a high voltage incident. Statistics have shown that it is usually the catastrophic explosive effect resulting from equipment or system failure that represents the greatest risk to high voltage workers' health and safety. Arc flash burns sustained by workers represent a significant number of serious injuries and deaths within the industry. Technicians may also sustain indirect injury from coming into contact with electricity. When they make contact with electricity while working aloft, electricity passes through the body that causes an involuntary physical or muscular reaction from the shock, and they may fall from a significant height. Though the shock may have resulted in minimal injury, the resulting fall may cause greater injury. Assessment is governed by WHS guidelines, as well as other jurisdictional, regulatory or administrative bodies. There are different approaches to working on low voltage and high voltage equipment, and both require implementation of safe systems of work. The first control measure is to eliminate the need to work on live equipment. This includes isolating the equipment from the source of supply. WHS regulations prohibit energised electrical work, subject to certain exceptions. For example, when fault finding, it's necessary that electrical equipment to be worked on is energised in order for work to be carried out properly. Next, is it possible to substitute something? An example is replacing low voltage equipment, power tools, with battery operated power tools. Is it possible to isolate or re-engineer things? One example is restricting technicians from coming into contact with electrical hazards using enclosures or restricted work areas. Control measures here include guarding or barricading, automatic disconnection of devices in the event of direct or indirect contact. Next are administrative controls. This includes providing training, use of access and permits, documented safe systems of work, planning and signage. Finally, are PPE controls. These include insulated gloves, protective eyewear, arc flash rated clothing, hard hats and breathing protection. However, the final two control measures do not change the hazard. They rely on staff behaving as expected and require a high level of supervision. Here, administrative controls such as procurement and personnel policies and procedures are critical in relation to electrical risks because they help ensure that electrical work is carried out by qualified electricians as required by the law. Vehicle access. It's important to consider access to land, signposting and warning notices. Accidents may still happen, but the impact may be significantly reduced. Other measures include holding pre-work meetings so that job safety analysis can be adequately assessed and considered, working in pairs or larger groups, ensuring workers have the knowledge, skills and experience to carry out their respective tasks, fitness to work assessments, continual risk assessments to ensure that site rules are adequately enforced on site. With regards to the risk of fire, though low, it's essential that everyone is aware of local fire risks, follow procedures and protocols established for the site, and follow basic common sense precautions that are typical in rural areas. And finally, these include not smoking on site except in prescribed areas, policing cigarette butts, that all vehicles keep to made tracks, that all vehicles carry fire extinguishers or firefighting equipment, and that all vehicles carry emergency communications equipment. In summary, it's impossible to avoid all accidents, though risk assessment should result in an accurate assessment to the level of acceptable risk. In saying this, hazards at each stage need to be rated according to the level of severity. And while some hazards may be extremely unlikely, they may have severe consequences. Therefore, any risk should be deemed to be unacceptable in this instance. Also, risks must be assessed at each stage of operation of a wind farm or of a single turbine, including identification, who is at risk and how they might be harmed by these hazards. Also, existing control measures must be noted, and if they are unable to fully control the identified risks, further control measures should be considered and put into action. The assessment must then be reviewed at regular intervals.